Attendance, group 6 later on, yeah. Okay, for first 10 minutes, go do your lab first. For Monday, there's a lab, also combined, yeah, because that's the only time the other group can make it. So our lab on Monday has to combine as well. Okay, cannot meet two separate groups because the other group cannot find a consensus what time they are available. All right, so the only time they're available is at 5:30. So I already put the announcement in A-Lib, yeah. So do your lab first, yeah. So I give you 15 minutes. Start the lab first.
Hello, sir. Sir,
Yes?
group 6 belum attendance.
Okay, apa later on.
Okay.
Alright. Okay, one more minute let's start 4:45, let's start. Okay. So any questions nak tanya? Yeah, hello? Okay, alright. Can you guys hear me?
Yes,
can
sir.
hear you, sir.
Alright. Okay. So untuk question 1, anything that you like to ask me? So basically ini insertion sort. Okay. So cara dia agak berbeza lah daripada you punya lecture slide. The way dia organize dia punya coding. Okay. Instead of apa beza dia kalau you perasan? Dayang Nadira? Apa beza dia Dayang Nadira? Dayang, are you there? Mana? Dayang mana? Aish, semua orang tak ada ke ni? Buka video everyone, nak tengok sekejap. Ada tak depan PC ni? Everyone buka video sekejap, nak tengok. Are you guys in front of your PC? Okay, Patrick, apa bezanya dengan you punya lecture slide dekat sini? Okay, first of all you have to understand in this lab saya perasan dia banyak use of recursion, which can be quite confusing lah, especially kalau you tengok bahagian merge sort. So that's why it's important for you to understand the concept. Okay, then you relate to the code. Okay, so Patrick, untuk insertion sort ni Patrick, apa beza dia ni dengan you punya lecture slide?
Is it the use of array?
Tak. Array tu is biasa lah. You just untuk store data. Cuba look at the code. Okay, so kalau you tengok you punya lecture slide, okay, dia benda yang sama, just that two different of implementation lah. Okay, yang ni dia guna while. Lecture slide dia guna do while. Compare dulu the first one with the second node. You perasan tak? Tapi dekat sini dia terus guna while loop. Okay, tapi method dia sama. I1, I-len is dia punya iteration kan. Bilangan dia buat perbandingan. Okay, tapi while ni dia guna instead of do while dia guna while. So so dekat while ni dia akan start dengan 1. Dan dia tengok if the value of the previous index is bigger than the current index, you swap. So dia punya logic masih sama. Okay, and then dia swap the value dalam array tu, lepas tu dia akan print the value inside the array. Okay, setiap kali dia sort, dia akan print value tu dalam array. Okay, so 5 nombor, 1, 2, 3, 4, 5, so perbandingan 4. Kenapa perbandingan 4? Saya dah terangkan semalam. Kenapa perbandingan dia 4? Dayang tak ada. Banyaknya tak ada kamera ni. Kuan Sian, what happened to your camera? Venorika, why perbandingan 4 Venorika? Cannot hear.
5 elements.
Apa dia Venorika? Cannot hear.
Because there are 5 elements.
Sorry Venorika, cannot hear you. I jump to another person je. Nur Syairah Ibrahim. Kenapa perbandingan dia 4 saja? Nombor 5, why perbandingan 4? Because you see, start pada 1 sampai length. Length dia berapa? Length dia berapa? Nur Syairah Ibrahim.
5.
Betul. So 1 to 5. So kenapa 4 perbandingan? Kenapa bukan 5?
Reduce.
Okay. So bila you buat insertion sort, you pasang tak? You akan banding 2, 2, 2. So 1, 2, first of all, you akan banding yang ini dulu kan? 1, kemudian you akan banding 2, kemudian yang 3. Now, the last one ni, you pasang tak? The last one bila dia banding ni, dia akan tengok nombor yang terkecil. Okay? Between these 4 numbers. So whatever it is, dia akan masuk to the last one. Okay, dia terkecil, the smallest one. Okay, so same concept with selection sort, basically. Alright, I think selection sort you nampak kan, see? Pemandangan 1, 2, 3, then the last one, the smallest one masuk yang keempat lah. Okay, because the last number, so it has to be the smallest one. Okay. Okay, so for the code, lepas tu dia akan print. So coding ni salah lah actually. You just need satu for loop aja. I don't know why they just use for loop, one for loop. Insertion sort J size 1, yeah, just use one for loop. Okay, should be correct, just one loop. Satu for loop je cukup, tak payah double. Alright, so please change inside you punya coding, ya. Okay, if no questions, go to question 2. Execute and observe the following code. Bubble sort program, fix the error in the output. Four, 5, 3, 2, 1, 2, 3, 4. Oh, salah. Five, 4, 3, 2, 1, 4, 5, 3, 2, 1. Okay. Have 10 minutes and look into the code and fix the code. So it prints out the array. So ini sama macam the previous question. So bubble sort with for print array. Okay. So who invokes bubble sort? Daripada main. So print array. Okay. So dia akan, so print array would give you the current value of the bubble sort. Okay, for the first one. And then the second one, bubble sort. So this one is the unsorted data, 5, 4, 3, 2, 1. So this one, yang ni, is the unsorted data. The first one, which is here. Okay. Second one is starting from here, dia sort sepatutnya. Tapi ada error dekat situ. So we'll see what is the error. So dia akan panggil bubble sort dekat sini. Okay. So you see when they call bubble sort, dia pass dia punya array and dia plus dia punya size. Kalau you disagree, beritahu saya ya. Kita buat sama-sama. So dia pass array, dia buat pass the size. So dia buat boolean function sorted sebagai true. Then dia have a integer j. Okay. What is j here? J here is basically used as a, so for loop, size minus j. Okay, so J is for the iteration. Okay. So we have Boolean function not sorted, sorted for as true. As long as it's not sorted, okay, dia kekalkan not sorted sebagai false. And then J++ is 1 now. Sorry, 2. After here, at line 26, it become 2. Okay. So for I, it start with 0. I is less than size. Okay, size is 4. Size is 5. 5 minus J. Okay, so J is 2. Oh, okay. So let's have a look at bubble sort punya gambar ya. Okay. Okay. So dia cakap I starts with 1. Okay. Now, dia ada basically 4 iterations. Okay, because for pair 1, 2, 3. Okay. So here you're going first iteration is basically for one number, second iteration two number, third number, fourth number. The last one will be the smallest one lah. Okay, so macam you tengok dekat sini kan, 19. The next number will be 16, and then third one would be 10. The last one will be 7. Then automatically the last one will be the smallest one. Okay. So if you look at the code here, iteration starts with 1. So these are adalah. So first for loop is the iteration. Second for loop is the index. You compare the value inside the array. So now you look at the code. Which one is the iteration? Which one is the index?
I is the index, J is the iteration.
Okay, all right. I is the index, J is the iteration. So what is wrong with the iteration here? If size minus J, okay, so size is 5. 5 at first glance, it will start with what actually? Size ni 5 kan? Tolak J. J 1, 2. Dekat sini, okay, J 1, J++, dekat sini dia dah jadi 2. So 5 minus 3 already, which is 2. Okay? So actually it's not the iteration here. You see? The problem now is actually the indexing. Okay? So okay, I give you 5 minutes. You tengok dekat sini dia punya indexing. Okay? And then you tell me how to fix it. Why is it wrong and how do you fix it? So dia punya iteration actually diganti dengan not sorted dengan sorted ni. Okay, so think about it.
Why? I think that the index part, it doesn't have any problem. I think the problem is with the J++. Should we just move the J++ after the process?
5 minutes first. Let your friends think as well. Then we discuss, okay? Okay, the technique is a little bit different as well for bubble sort in this implementation. What I want you to do is tell me how is it different as well, yeah? Kalau you tengok dengan you punya, both are correct, both implementation is correct, but this one is using different technique. Okay, so tell me how is it different? Okay, so I give you another 5 minutes. So you need to understand actually the technique they use here. Okay, kalau you perasan dekat sini this print array is called multiple times. Okay, so tak apa. You look at this one and then you see how the technique is different. So I give you another extra 5 minutes for this one, yeah. Okay. So if we use this current code, ya, berapa kali iteration dekat sini? I mean, berapa kali dia punya perbandingan dekat sini?
3.
The first one, if this current with method, it is 0, 1, 2. So it's 3. Tapi nombor dia ada berapa? Number dia 5, okay? So you have index, let me see, you have index 0, you akan ada index 1, you akan ada index 2, okay? So you have 0, 1, 2. Okay, tapi your number you have 5, okay? So you have 5 numbers. So if you have 5 numbers, that means you want to compare. How are you going to compare here? So you can start compare kosong with the next value. But if this one is already 2, okay, that means 3, okay. So you kena compare berapa kali dia buat perbandingan dekat situ. So if J is 1, you akan dapat 0, 1, and then 2. Okay, and then terminates. Alright. But if J is kosong, so J plus plus here will become 1. So size 5 minus 1 will be 0, index 0 to index 4. So index 0 up here, compare 1, 2, 3, 4. Previously it's 0, 1, 2, 3. So it's short by 1. So execute, compile and run. So you dapat 1, 2, 3, 4, 5. Okay? Okay, that's my first answer just now. So the second answer was, how is it different from the one inside your lecture note? Okay, I give you another 5 minutes to think that one, then someone give me the answer, yeah? Anyone want to try? Sorry. Liu Xuan, any ideas?
Isn't that same? Just the type of writing, the way they're writing the condition different a little bit. For the inside our lecture, it says that although the iteration will continue adding.
Slow. So the iteration, slow, Okay, the iteration.
The iteration count continue until it reach it is greater than the length, then it comes out from the loop, the for loop. But for this, it set a condition with the bool, not sorted.
The boolean.
The boolean.
Okay.
But I think there are same numbers of doing the comparison.
Yes, it's the same number.
Doing the sorting.
So inside your lecture note, so they already set the iteration basically.
Yeah.
Okay. But this one, they actually implicitly they count the iteration dekat sini. Because you see, dia akan keep on cari if you run the code, not sorted through ni, bila dia dah check semua AR. Okay, for the first iteration, kalau you perasan dekat sini kan, so basically katakan 5, 4, 3, 2, 1. Okay, dia akan compare 5, 4 ni dulu. Okay, lepas tu dia akan swap. Okay, now you kena tanya diri you dekat sekarang ni, when dia actually akan buat not sorted through ni?
When the index is smaller than the length of the array minus iteration.
Yeah, okay, alright.
Correct. Yeah.
Betul lah. Okay, so you tengok dekat sini, if you execute, compile and run kan, dia akan compare the first two dulu. Okay. Lepas tu bila dia sampai dekat 4, 5 ni, dia dah buat dekat sini kan, dia dah exchange, dia dah swap temporary, not sorted, dia akan buat sebagai true. Okay. Tapi kita tak exit for loop ni lagi. You exit for loop ni bila semua dah sorted actually. So bila everything, because this one is for loop from 5 I0 kan, until the I0 daripada until this last number, dia akan keep on sorting. Okay. So dia not sorted, dia akan set sebagai every time dia tukar, dia akan set kepada true. Tapi because of the iteration, dia akan implicitly, dia akan tiap-tiap kali masuk sini satu, dia akan sort. Okay. So bila dia exit loop ni, dia definitely, what happens is, dia definitely akan exit for loop ni. By the way, the print is inside the for loop tau. So bila dia print ni actually not fully sorted yet. This all not fully sorted. So bila dia exit for loop ni, not sorted ni, definitely dia akan jadi true because dia dah sort kan. You perasan tak dia punya coding dekat sini? If 5, 4, ARI is 0, ARI 0 is 5. Okay? And then ARI 0 plus 1 is 4. Okay? So is this true or not? So ini adalah 5 bagi besar pada 4 kan? Okay? So dekat sini, if 5, let me see. Betul lah. If 5 bigger than 4, then dia tak akan execute ni, dia akan print dia punya array. Wait, sorry. I salah ni. Wait, Sorry, I'm confused. Okay, the number was 5, 4, 3, 2, 1. Now, if you set j to 0, okay, for I is 0, so ARI 0 would be 5. Okay, if I value 5. ARRI plus 1, that means index 1, dia akan jadi 4. Okay. So, bila dalam keadaan tu, dia not sort, actually it doesn't sort the array.
Yeah. So I understand it better with I I put the print array out of the for loop. Just after the for loop for the iteration is smaller than size minus j, and then I can see that the code is like they sort the first element in the array, just array 0. They just keep compare 5 with the second element, third element, fifth element until it is sorted, and then it will print array. After it print a sorted array, then it keeps not a completely sorted array, just sorted one element array. And then they will go back to the for loop with the j plus plus increase the iteration, and then it continue next element to continue to sort the second element.
Okay, right. If your method gets the sort, then if your method is able to sort it, it's correct lah. Okay, but I made an error just now when I read this code. Instead of reading it's bigger than, I read it's smaller than. So that's my mistake just now. Okay, so class, just give me another 5 minutes. Saya yang silap tu. Give me another 5 minutes. Let me just check back twist back my code, yeah. Ayuh.
Isn't it right? Wait. Sir, your code tak ada masalah lah actually. Hello, sir.
Yes, Lisa.
Can you look at the chat box?
Yeah, sure. Okay. Yeah, I just not trace my code. I think there's when I put the output a bit wrong here. So let me just see. Takut I don't want to say the wrong thing. So just give me time to just double check my. Okay, thanks. Okay, thank you, yeah, Liu Xuan, for participating in the discussion. Okay, for Patrick, yes, first of all, it will print the value 54321. Okay, but if you go inside this loop here, okay, for I is 0, I is less than size minus 1, because j is 0, you plus 1, so I would be I minus size minus 1 would be I is 4, I plus plus. But the first coding here, if you look at the numbers, it is 54321. Okay, so AR0, which is 5, is bigger than ARR I plus 1, which is the index 1. Okay, so this here is not executed. Okay, so it keeps on repeating itself until 1 here. Okay, but supposedly it was supposed to sort these two. So yeah, I'm actually having
Which
trouble.
two, sir?
Excuse me?
Which two? I cannot see your
Oh.
pointer.
Okay. Sorry. Okay, so if you see kan, kat sini ARR kosong will be 5 kan? Because the number is 5, 4, 3, 2, 1. So this is index 0, 1, 2, 3, 4. Okay? So ARR kosong, which is 5, is bigger than ARR 1, which is 4. So this is actually, this condition here is not invoked. Okay? So you're going to print the array. If you execute it, okay, bubble sort steps. First one, it will print out 5, 4, 3, 2, 1. Okay, so it is this one here. But the next bubble sort, it is 4, 5, 3, 2, 1. Okay, so meaning that this one, now the problem here is that this is never executed. Okay, because why? 5 is bigger than 4. Okay. Previously I read it wrong. I read it like this. So the code is correct. However, my tracing is a little bit wrong. Okay. So I still haven't reached how I'm still unable to find why is it able to change to 4 to 5 here. Why?
So maybe because you use the old version, because in the updated version, I copied in exactly same like this one. Just the arrow is array I is greater than array I plus 1.
Yeah. I'm using the correct version. Yeah, it's the correct version lah. But the logic is I'm just the logic here because it's never invoked. Okay, so if katakan if you go the next one, the next iteration, right? Okay, so here I plus plus. So first one is AR, so A5 is bigger than 4. So this one is not invoked. 3, 2, 1. So supposedly when you do this bubble sort, right? This one should be 5, 4, 3, 2, 1, but I haven't been. I'm thinking my tracing is wrong. It gets 4, 5. It was sorted. So this is the part that it's not the same as the code.
You want the result be not sorted for the first for the second line?
This is actually correct. 4, 5, 3, 2, 1. This is correct actually. But when I trace it, but probably when I trace it, it is okay. So 5 is bigger than 4, so it's not executed. Correct?
No, if 5 is greater than 4, then it will swap, right?
Oh my god, 5, yeah. Yes, correct. Oh yeah, betul. Ayo. Okay, correct. So 5 is bigger than 4, then it is executed, then it is swap. My mistake. Ayo. So, yeah, dalam kepala saya tak executed lah. Sorry, long day for me lah today. Yeah, so betul lah. If 5 besar pada 4, okay, so dia akan swap nombor ni. Okay, so bila dia swap, okay, so 1, 2, 3 ni dia akan swap. Not sorted ni, dia akan letak sebagai true. Okay, dia tak keluar daripada while loop ni dulu kerana dia kena sempurnakan whatever that's inside the for loop. Ayo, sorry for making you guys waiting for so long. So inilah, this is correct. 5, but because 5 is more than 4, then this will be executed. In my mind just now, because 5 is more than 4, dia tak executed. So it was my mistake. Okay. So the difference is basically, okay. So sekarang ni, dekat the first punya iteration tu dia dah buat not sorted ni, dia dah setkan sebagai kepada true. So bila dia naik, okay, so dia yang ni, execute, compile and run. So for this one, 5 besar pada 4, so dia akan swap. So dia akan dapat 4, 5. Okay. So itu untuk kosong, that one is for ARI kosong and 1. Okay. Dia naik balik, next one ARRI akan jadi 1, then this one akan jadi 2. So 1 dan 2, 4 dan 3. Okay. So bila 4 dengan 3, so tadi ini dah swap. Okay, so dalam you punya array sekarang, the first iteration now, just now, was 4, 5, 3, 2, 1. So the first one, the first iteration ni kan, you akan ada 4, 5, 3, 2, 1 because dia swap. So bila next one, dia akan jadi I adalah 1. So AR1, adakah ianya lebih besar? Is it bigger than ARR2? Okay, so ARR1 this time is 5. Okay, and is it bigger than ARR2, which is 3? If it's true, then dia akan swap. Okay, so it will keep on swapping until it exits the for loop. Bila dia exit the for loop, not sorted ni memang akan jadi true. Even the first iteration dia sudah true. Okay, any questions? So sorry about that one ya. Ini saya yang salah baca tadi, my mistake. Okay. So if no question, we can go to the next question. So Patrick Owen, the first one, just to clarify, print array ni akan keluarkan nombor 54321. This one. Okay. First iteration of the for loop sini akan keluarkan your 45321. Because why? After if, okay, dia panggil display. Okay, so you sort 4, 5 tadi. Lepas tu second iteration, remember ya, bila you swap ni, 4, 5 ni dah jadi permanent dalam you punya array. So nilai baru dalam array you adalah actually 4, 5, 3, 2, 1. So the next iteration dia akan swap 3 dengan 5. Okay, so bila dia dah swap kan, dia panggil balik array tu, that's why you dapat 4, 3, 5, 2, 1. Okay, is that clear everyone? Is one correct? Okay.
Yes.
Okay, but I'm not sure is it the same with your solution, what you were explaining just now.
Yes, it is the same.
Same. So I'm sorry, that was my mistake just now. A bit of a long day for me, ayo. Okay, alright. Thank you, Liu Xuan, for participating. Okay, if no questions, kita pergi kepada question 3. Transform the bubble sort in question 2 into a linked list implementation. So you use, okay, so this one, the coding is already given. Okay. Alright. So you create a node. So here you print the bubble sort. Okay. So here is where you create the list. So basically the data is given an array. So you're going to have to create it into a linked list first. So we invoke this one here. So this is like your previous lab. Okay, you have to create the linked list. So you haven't sorted it out yet. And then you print out the list. So you invoke print list over here. So as long as you haven't reached null, you're going to print out every value inside the list. Okay, this one should be clear already. This is basically the same like your last lab. Yang different is the bubble sort punya function. So bubble sort, okay, so they use a Boolean function, true. So you have variable count, j, temp, and so you have a pointer called current that points to the linked list. Okay. So as long as current has not reached, as long as current is not null, okay. So what does this mean? As long as current is not null, current will be pointing to next. Okay. So we'll look at the next node. Okay. So here is a while loop actually. Give me a second, yeah. So as long as current is not null, current is going to keep on moving. So it moves to the linked list. Okay, why does it move to the linked list? Okay, so the count here actually, every time it moves into the throughout the linked list, this count is going to basically keep track of the number of nodes. Okay. So now it has the number of nodes available. So now it uses a for loop dekat sini. Okay. Now current is going to be pointing back to the list. As long as current is not null, they're going to compare the data. Okay. If current data is bigger than the next node, then you're going to swap the value. How does it know when to stop? Basically, because you're going to keep swapping just like previously, like the bubble sort 5, 4 tadi kan, 5, 3. Dia tahu because dia dah sekarang ni dia tahu. Tadi dia tak tahu. Dia tahu because dia dah traverse before the linked list by keeping whenever it travels one node to another node, it increases the count number. So that's why dia tahu bila nak berhenti using for loop. So if the value of current is bigger than the next node, then you swap because the bigger one needs to go in front. Okay, and then every time you perform this swapping with values between the different nodes, dia akan display dia punya swapping outcome lah. Okay, because whenever you swap, dia display dia punya outcome kepada you. So wait let me close. Okay, so bila you swap ni 5 hingga 4, okay, kat sini dia print dia punya outcome. Okay, bila dia naik balik, dia swap, dia print dia punya outcome. Dia tahu kat mana dekat berhenti. When it knows when to stop. J is less than count because why? This count you already know the number of nodes. So dia akan compare from the first one up to the last one. Okay, any questions? So linked list I think is simpler than the array. Okay, but to be told, the array was actually simpler lah. Not simpler, simple, but just that tadi saya buat mistake of the evaluating the condition. Alright, so bubble sort is the same. Okay, but actually it's easier because the only thing is different is that the use of this count to count the number of nodes. So basically to perform using linked list, okay, you need to traverse the linked list first to get the count value here. What is the count value? The number of nodes. Only then you can create how many times you want to make the comparison you need to make. Because you need to you kena berhenti at the last node. Alright, any questions? Okay, if no questions, kita pergi dekat selection sort. Next question. Okay, give you 5 minutes to have a look. So selection sort is this guy here. So this one compare. The last comparison, obviously the biggest number would go to uh, the last node. Okay. Okay, so what's different between this lab with your lecture note? Ini dia terus combine swapping dekat dalam selection sort. Dalam you punya lecture note, swapping is in different function. Okay, so swapping dia akan letak sebagai a different function. Selection sort we will call the swapping function. Okay, have a look at this code first. I'll give you 5 minutes. Okay, so for this coding, same like your lecture note, no difference except for the swapping. So kalau you tengok dekat sini, I start with the first element up till n minus 1. Same with your lecture note. Okay, so it will find a minimum index is I0 first, at first lah. Then this one we increase to 1, 2, 3. Okay, up till n minus 1. Okay, less than n minus 1. So it compares the first index just now. Okay, now it compares the first index, minimum index ni, dengan the next index value and the value after it. Okay, if it finds whereby the value after min index ni is smaller, okay, then dia akan swap. Okay, so meaning if there is a value that is smaller than any value that in the minimum index, any value dalam index that is not the minimum index, here is 0 lah. That means the next one would be 1, 2, 3, 4, 5, 6, 7, whatever it is. As long as it is smaller, then it will swap it with the value of the minimum index. Okay, and then the new minimum index value would be, so here kalau you tengok, this is where the swapping happens. Okay, so this is where the swapping happens. Dekat minimum index adalah J, so dia swap. Okay, so this one is actually the same as you punya lecture note. Dia jumpa, dia swap. Dia jumpa, dia swap. Okay, so any questions regarding this one? So what, dia swap the value, yeah? It swaps the value. So any questions? Okay, if no question, we proceed to the next question. For selection sort, it's the same. Okay, quick sort is different. Okay, so copy and paste your punya quick sort ni, and then you see the difference between the one inside your lecture note. So for quick sort, I think I give you 10 minutes for that one. So it's different than your lecture note. Okay, ada tanya tadi dekat mana dia swap. This one is balik kepada selection sort tadi. Okay, now ARI adalah kosong. The first value tadi, dia swap because mean index ni dia tukar kepada J. So here is ready, basically, it's not I anymore, it's actually J. So kosong ni dengan value whereby the value satisfy, it is smaller than the current minimum index. So this is where it swap. Dia bukan J ni, I ni, minimum index daripada I, dia dah tukar kepada J. So that's why dia dapat swap. Konsep dia sama je actually, just that the coding dia guna different method. So sini actually dia dah tukarkan I kepada J, that's all. Okay? Okay, so quicksort tu bit different ya.
So for the second 7, when we
Sorry?
compare 7 with 7,
Uh,
is it larger or smaller?
Sorry, which question is it?
Yeah, for the quick sort.
Quicksort. Yeah.
Ah,
Okay.
in the array that contain two 7, number 7,
Uh-huh.
and my first pivot is array index 4, so it is 7. And when I come from the J, from the which hand side? Wait. Yeah, when I come from the right hand side,
Mm-hmm.
I need to compare 7 and 7. So this condition, what should I do? Is it larger or smaller?
No, if it doesn't fulfill, then it doesn't fulfill the condition, like it goes out lah.
Oh,
Okay? Are you referring to the while or if, by the way? While, right?
Yeah, wow.
Yeah, it doesn't fulfill the condition, doesn't go in.
Okay.
So it's like 7 dengan 7 kan? Is 7 less than no.
Yeah.
Doesn't go inside the the loop.
Okay.
So first you will print the array, and then quick sort, you will pass the array from index 0 till 8. Okay? 0 till 8. 1, 2, 3, 4, 5, 6, 7, 8. So for quick sort, it passes the lower index and highest index. Okay. So period is the medium. So it will be at 4. 1, 2, 3, 4. 0, 1, 2, 3, 4, 7, 7. Okay. So what happens is that it compares as long as your I and J, okay, which is 0 and 8, okay. So ARR, I starts with kosong, okay, is less than 7. Your pivot, okay. Oh, sorry, your pivot will be 4. So the value of pivot, oh no, sorry, your pivot is 7, because this one is the array value, okay. Now, if this condition is fulfilled, then you move, okay, dia punya index ni ke kanan, okay, because I is left, okay. So this will keep on happening until the value of ARI, this one, okay, is equivalent or more than the pivot, okay. If it's more, then it will we execute the second while loop. Okay, so basically it will keep on repeating itself until it traverses the whole array. Okay, so whenever there is a crossover, you swap. Okay, so now only after that, okay. So every time you would have performed crossover, you can print out the value, okay. So this one is where it calls this function to sort the left subtree and sort the right subtree. Okay. Now inside your lecture note, a little bit different because why? Dekat sini. Okay. If list index is less than pivot, dia increment, tapi dia akan swap small index ni, the value of the ni left subtree, left subtree, dia akan swap small index ni dengan value dalam array tu yang doesn't belong in the left or right subtree yet. So this is a difference you punya lecture note, okay, and your textbook. Okay, so your this one here is more like your example. Okay, so when there is a crossover, then you're going to swap. All right, and then you perform recursion for the next swapping. So left subtree and the right subtree. So this one here. Okay, so left half and then right half. Just that the coding for this one does not reflect 100% of this one. This one dia ada basically dia punya array tu, kalau you perasan your textbook tu, dia dah a value inside the array which does not belong on the left or right yet. So they need to classify it first. Okay. So okay, so this one the coding is the same with your example. So any questions regarding quicksort? So Liu Xuan was asking lah, is 7 what to do 7 7? So is 7 less than 7? No. So we exit the loop. Okay. Okay, no question. Next is merge sort. So merge sort quite long. So we start with the concept first lah, merge sort. Okay. Okay, the concept of merge sort basically it's like this. So you divide till the atomic level like this. Is the atomic level, and then you merge. So if you notice, recursively you have to keep on breaking it until you reach the atomic level, each single unit, and then you compare and merge. Compare, merge, compare, merge. So if you see the merge here, this is submerge, 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 submerge have to be remerge. So when you look at your code, you need to see which actually, first of all, first process, the one that divides it into smaller parts. In smaller parts. So if you go to main, okay, so you're going to print out the original data. So you get the original data first, this one here. Then you go to the sorted data, merge sort here. So merge sort, you go here. So this is the function that breaks it into atomic level. If you notice, it is recursive call. You see merge sort kan, satu function, dia pecah, same 4 jadi 2. Then 2 divide 2 jadi 1. Then you get your atomic level. So here is where you divide. Okay. Now after you divide, okay, so you see merge sort, divide by 2, go to merge sort low and mid. Tak habis tau. Dia pergi merge sort dekat sini, dia pergi panggil diri dia balik. So it keep on simpan dalam buffer until it reaches an atomic level whereby low does not, is no longer, low is no longer bigger than high. Okay. So when low is bigger than high, or the same value, only then, okay, it will go. So ini dia akan exit bila low is bigger than high. Okay. So every time you see merge sort, panggil balik. When you low is no longer bigger than high, then only it goes to the next one. So you akan ada left and you akan ada right. So sama dengan right ni, it has to keep on breaking it. Okay. Then finally, bila dia dah not fulfill this condition anymore, dia akan merge the two arrays. Which is this one here. This code here. Okay. So here you try to imagine you ada nombor 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 0 and 11 you divide by 2. So you get 4.5. Okay. So which is 4. And then 4 divided by 2 again. And then finally at one point, this will be no longer fulfilled. Then it goes to the merge sort. Okay. So this will keep on repeating itself. Okay, until you reach the atomic level. This one here. Because it keeps on dividing it. Okay. After, so it is all partial solution. Okay. And then you try to, bila dia sampai apa ni, dia punya atomic level, it is all partial solution up till now, ya. And then baru dia akan merge. Okay, so untuk dia merge, dia need to compare. So 35, 28, which one is smaller, then they merge. So this is where the comparison happens. Okay. If it's smaller than the left index, if the left index is smaller than the right index, then you put it into okay. So bila untuk merge ni, dia akan put it in a temporary array. So that's why this TMP is called a temporary array. Okay. So it will keep on merging. Okay. So the first one will be a partial solution for these two numbers first. Okay. Then it needs to merge both left and right. Okay. So this is left, right. So merge this left and right. So that is accomplished using these two while loops. So this is for the left. This is for the right. And then finally, from this temporary array, baru dia akan merge it with the original sorted array. Not merge, sorry, replace to the original sorted array. Okay, so the value of original sorted array, basically where the action happened is at this temporary array lah. Okay, just that this coding wants to separate the temporary array with the original array, and the one that's been displayed is the ARR sort later on. Okay, this one. Okay, so this one will be rewritten by the temporary array. Alright, so break into atomic level here, but it's all partial solution because why? It keeps on calling itself back. Okay, once this is inverted, the last one whereby it is where there are the single values, then only they akan merge, whereby they akan compare the value. Alright, bila compare dia akan merge tapi dia submerge. Okay, so you akan ada left and right. Semua ada left right. Okay, so in the end you have to gabung the left with the right. So that is through this while loop here. Alright, finally bila dia dah merge, so how do they merge? You see the index different, left index, and the index is also a right index. So the indexing is actually a one array, but left subtree akan masuk this part, right subtree akan masuk the next part. But the array is actually one array only. The indexing is where it keeps track of the left subtree and the right subtree. Okay? Any questions? Okay, so this one you can try back by yourself. I think it's quite similar to the one inside your textbook. The only difference is the one quick sort, yeah? So if no question, that's all for today. Your class with me next week will be on Monday as well with your lab. Okay, Monday as well. The lab we have to merge as well because you guys are free only at 5 something, right? Okay. Alright. If no question, that's all for today. Attendance, group 6. So attendance for group 6 here.